Hello everyone, good day. In this video, I'm going to discuss with you the chapter 2 of our week 6, namely the atom, a look inside, and specifically section 1.1 of chapter 2, the atomic structure. In this video, I'll be discussing these topics. First, the modern atomic theory. Second, the atomic structure. Third, atomic theory. And the last one is the subatomic particles, namely proton, neutron, and electrons. So objective of our week 6 are trace, you have to trace the development of modern atomic theory. You need to describe the structure of atoms. And lastly, you need to differentiate the subatomic particles. Okay, the first one is modern atomic theory. In ancient times, philosophers and scientists had been asking, what are things made of? Let's say that you are one of those Asian philosophers. Would you still ask this kind of question? Ano kaya yung gawa ng mga bagay? What are things made of? Ano kayong napaloob sa t-shirt mo? Okay, so it was Empedocles who proposed the concept of fire, air, water, and earth as the answer. Siya yung kauna-unahang philosopher who answered this question. Well, hindi natin masisi si Empedocles that he answered the four elements of the nature since ito yung pinaka-common na makikita sa palibot natin. This was then accepted by Aristotle. He even added a fifth element which he called quintessence. Quintessence, according to ancient and medieval science, is also called aether or ether. It is the material that fills the region of the universe above the terrestrial sphere, made up the worlds of the outer celestial spheres believed to surround our own world. Okay, the world describes the medium of space. So Aristotle added a fifth element, quintessence, but it cannot be seen here in a terrestrial field. Okay, it was then Democritus who assumed the presence of a void in which the unchanging particles were in continuous random motion. Later, he then came up with a theory stating that everything is composed of small, indivisible particles which he called atomos. Okay, in terms of the theory of Democritus, when we say indivisible particles, ito yung mga bagay na hindi na natin nahati. Okay, the atomos of Democritus, example, you have a stick. Pag hinati mo yung stick at hinati ng hinati, yung indivisible particles o yung pinakalas na particle na di mo na mahati, yan daw yung atom based from Democritus, which he called atomos. It was only after so many years later that a concrete atomic theory was made. So the atomic theory was made by an English chemist named John Dalton. He proposed that atoms have fixed weights and different properties. This is known as Dalton atomic theory. Okay? In 1869 to 1975, William Crookes developed an electrical discharge tube with vacuum. He passed an electric current through a gas-filled tube provided with electrodes sealed at both ends. A stream of gas was pumped out of the tube. A certain pressure was reached at which the remaining gas glowed. According to Crookes, the glow was produced by negative particles called cathode rays, passing from the cathode toward the anode. The glow was produced by particles that missed the anode and hit the glass. So later, I will explain what is this cathode rays on pag dumating na tayo doon kay J.J. Thomson. Okay, Crookes' experiment about the cathode rays helped English physicist J.J. Thomson in the discovery of the electron 80. Class, it was J.J. Thomson who discovered electrons. So this how it looks like yung cathode ray. Yung cathode ray tube, class, is commonly makikita siya sa mga yung mga old TVs. Okay? If you have observed or meron na kayong nakitang nabuksan na TV sa likod niya, napansin yung parang meron siyang parang funnel shape na glass. So that is an example of a cathode ray tube. Okay, it is commonly used in TVs kasi sa time natin ngayon, uso na yung mga flat screen TV, so hindi na siya masyadong evident. So what happens in a cathode ray tube? Okay, in a cathode ray tube, this is a vacuum tube. Ibig sabihin, kinuha yung mga hangin o yung mga particles na napaloob doon sa vacuum. Kasi hindi makikita yung electrons na sabi ni J.J. Thomson pag hindi natin kinuha yung hangin o yung other particles doon sa loob ng tube. Mga bagay nandoon sa cathode ray tube. First, we have a cathode. Okay? Itong cathode is a negative charge Another one is an anode. Okay? When we hit the cathode by high voltage, example yung mga battery na high voltage, there is a glow that emanates from cathode to anode or parang siyang light na nag-pass through. Okay? In the picture, it glows in a color green. The light emanates from cathode to the anode. Okay? And when it hits the tube, since the tube is made of zinc sulfide, it creates a green glow. Okay, so J.J. Thomson said that this glow is an electron and this is a negative charge particle. Okay, so bakit kaya nasabi ni J.J. Thomson that this is an electric charge or a negative charge? Okay, kasi once we put a two charges dito sa gilid, example, we have a positive charge plate dito sa ibabaw, and dito sa baba, we have a negative charge plate. Sa tingin nyo, saan kaya liliko yung glow? Upper or below? Okay? The correct answer is pataas. It is because opposite attracts. Okay? So the negative charge attracts the positive charge. So pag ininit natin itong cathode na negative charge, mag-create siya ng glow in a straight line. Okay? Pero pag once na naglagay tayo ng positive charge plate dito sa ibabaw and a negative charge plate dito sa ibaba, yung glow, magbe-bend siya above papunta doon sa positive charge. So pag change na naman natin yung charge plate, dito na naman sa ibabaw yung negative charge and dito sa ibaba yung positive charge, okay, so yung glow magbe-bend naman siya pababa. Okay? So why did they name it as cathode ray tube and not as anode ray tube? Do you have any idea? Okay, they called it cathode ray tube since yung light or yung electrons, it emanates from the cathode to the anode. Okay, kasi nga opposite attracts. So yung cathode negative, so it went straight to the anode which is a positive charge. Okay, so in the ancient times, hindi pa nila alam ano yung mukha ng atom. So it was in 1904, he used the plum, J.J. Thomson also used the plum pudding model to demonstrate that atoms are made up of these negatively charged particles. So ano ibig sabihin nitong plum pudding model ni J.J. Thomson? Okay, so we have a ball, a sphere, and sa loob ng sphere is meron daw mga seeds parang katulad nitong watermelon. Okay? J.J. Thomson indicates na itong ball is a positive charge. Ito daw yung mukha ng atom dati. Itong sphere is a positive charge and yung mga negatively charged are spread across doon sa positive sphere. Katulad nitong picture na watermelon, itong color red na part, na fleshy part ng isang watermelon is the positive charge and these black seeds are called or are the negative charge. So tinawag siya ng plum pudding model because it looks like a pudding na pagkain, katulad nito na picture. Okay, let's proceed. In 1909, American physicist Robert Millikan determined the charge of an electron. He concluded that electrons are identical and they are components of all types of matter. From the electron, Ernest Rutherford in 1911 measured the deflection of alpha particles aimed at a metal film and observed that most of the metals were not deflected. So, in this right side, itong picture sa right side, this is the actual picture of the cathode ray tube that was used by J.J. Thomson. Okay, yung kanina is cathode ray tube na makita siya sa loob ng mga TVs, ganyan. So as you can see, there is still a cathode, a negative charge, and dito sa other side is an anode, a positive charge. So ito yung example class nung nag-bend na color green na glow kasi merong charge plate na nilagay sa ibabaw. So ibig sabihin itong charge plate na ito is positive since nag-bend sa ibabaw kasi itong glow is a negative charge. This made Rutherford concluded that the concentrated mass in the middle of the atom is present, which he called the nucleus. Okay, so what happens in the experiment of Ernest Rutherford? The experiment of Ernest Rutherford is called the Guilfoyle experiment. This experiment made a breakthrough in chemistry, for it corrected the wrong structure of J.J. Thomson, which he called the plum pudding model. Okay, so this is how it looks like in the Goldfall method of Ernest Rutherford. Okay, in his Goldfall method or experiment, there is an alpha particle as a radioactive source. Okay, so why did he choose an alpha particle? Okay, do you have any idea? Okay, this alpha particle is a heavy material. Ibig sabihin, it can just pass through in dito sa Goldfall na nasa center. Another one is that this alpha particle is also a positive charge. So, sabi doon ni J.J. Thomson sa plum pudding model niya, yung structure doon ng atom is a positive sphere na yung parang watermelon and yung mga seeds is the negative charge. So, since this alpha particle is also a positive charge, ibig sabihin it will just pass through doon sa gold foil. Okay? Another one is that this alpha particle travels fast. Okay? So, ibig sabihin, mabilis siya. Kaya, in-enclose rin ni in-enclose rin ni Ernest Rutherford itong alpha particle into a lead box with a very small slit or butas dito. Bakit kaya? Okay, it is because para yung mga alpha particle will travel only in this butas. Dito lang siya lalabas. Kasi pag hindi naka-enclose yung alpha particle in a lead box, ibig sabihin yung alpha particle will travel in a different directions. So hindi magkakaroon ng response katulad nitong straight line pag walang lead box. Another one is that there is a gold foil in the center. Bakit kaya gold foil? Okay? The purpose of this gold foil is that kasi yung gold is a very malleable metal which is pwede siyang gawin into a very thin sheets. Yan yung isang property ng gold and a property of metal. Another one is we have here a fluorescent screen na meron siyang gap dito. The purpose of this is that malalaman natin na yung alpha particle nag-pass through na dito sa gold foil and tumama na dito sa fluorescent screen. It is because when the alpha particle hits the fluorescent, it will create a light or it will glow. And meron siyang gap para dito dadaan yung alpha particle. Okay, so in the gold foil experiment of Ernest Rutherford, if babasihan natin doon sa plum pudding ni J.J. Thomson, dapat daw itong alpha particle will pass through lahat-lahat dito sa gold foil kasi nga sabi doon sa plum pudding model, positive sphere with electrons at the center or with electrons across doon sa plum pudding ni J.J. Thomson. But on his astonishment, Ernest Rutherford discovered that some of the particles or mostly of the alpha particles pass through, which is correct. Nag-pass through dito sa gold foil and it hits the fluorescent screen. Yung tinatawag natin undeflected beam. And another one is that may napansin siya na meron daw nag-deflect na light. Ibig sabihin, deflect na light or particle, ibig sabihin, hindi siya nag-pass through siya doon sa gold foil pero lumiko. It was deflected. And one thing that shocked Ernest Rutherford is that merong nag-rebound ng mga particle. Ibig sabihin, pag tama doon sa gold foil, bumalik siya. Okay? So sabi ni Ernest Rutherford, ibig sabihin mali yung model ni J.J. Thomson which is plum pudding model. Kasi meron nag-rebound and meron rin nag-deflected na dapat lahat-lahat daw mag-pass through. Okay? So what happens in this gold foil method? Example, we have a cotton ball. Okay? And in the middle of the cotton ball or at the center, there is a heavy and a very hard sphere. If you have imagined, example, cotton ball, then meron siyang hard sphere dito sa gitna. Ibig sabihin daw nito na yung mga atoms meron ng mga spaces. Ibig sabihin, maliit lang yung nasa gitnang hard sphere kasi almost daw ng alpha particle nag-pass through. Okay? At yan yung mga unflected beam. Pero yung mga deflected beams, ibig sabihin daw, it hits yung middle sphere sa side niya, kaya nag-deflect, or it was deflected by the hard sphere since itong nasa gitna daw nitong cotton ball or itong atom is a positive charge. And itong alpha particle is also a positive charge. Therefore, hindi sila nag-attract. So, they deflected each other. And Ernest Rutherford also concluded that these rebounded beams or alpha particles hit directly in a straight line yung gitnang hard sphere sa cotton ball or an atom. Kaya siya nag-bounce back. Okay? If you look in this figure, ito yon. Example, ito yung mga alpha particle. Nag-pass through siya kasi hindi niya na-hit yung sphere o yung hard sphere na nasa gitna ng atoms. Ito naman is nag-deflect, nag-bend siya because it hits pero sa side lang ng sphere where it was deflected since they are both positive charges. And this reflected beam or rebounded beam hit directly in a straight line yung positive sphere sa gitna, kaya siya nag-rebound. So, Ernest Rutherford concluded that most of the space inside an atom is empty. Another one is that positive charge occupies a small space inside the atom. Bakit kaya a small space lang? Okay, it is because kasi pag malaking space, itong positive sphere na nasa gitna, dapat maraming na-deflect and maraming nag-rebound. But in the experiment, maraming nag-pass through. Ibig sabihin, sobrang liit lang nung positive sphere sa gitna. So this Goidfall method corrected the wrong structure of J.J. Thomson, which is the plum pudding model. Okay, let me go to the next. In 1913, Danish physicist Niels Bohr suggested that the total energy of an electron is quantized, restricted to having only certain specific values, particles called atoms. This became the basis for the modern atomic theory, which states that matter is composed of small particles called atoms. Okay, next one is the basic laws of matter. As the modern atomic theory was continuously developed, scientists certain rules to better understand the things around us and the principles that explain their behavior. So there are three basic laws of matter. First is the law of conservation of mass, proposed by Antoine Laurent Lavoisier, known as the father of modern chemistry. The law states that the mass of the products in a chemical reaction be equal to the mass of the reactants. So example nito is hydrogen plus oxygen, dapat daw yung mass ng hydrogen and ng oxygen is equal to the product. Example, we have two hydrogen atoms and we have one oxygen atom. So pag kinumbine natin sila chemically, we will gonna have a H2O or water. Example, the mass of the hydrogen is 5 and the mass of the oxygen also is 5. Therefore, yung product natin is 10. Kasi dapat daw in the law of conservation of mass, equal yung mass ng reactants and equal yung mass ng product. In other words, matter can neither be destroyed nor created. No mass is lost in a chemical reaction. So in a chemical reaction, walang patapon. Ibig sabihin daw, kasi matter is cannot be created nor destroyed, ibig sabihin, in any reaction, walang mababawas and walang madadagdag. Doon lang tayo mag-stick sa mass ng reactant and it will be equal to the mass of the product. The next one is the law of constant composition. The law was discovered by the French chemist Joseph Proust. This law states that all samples of a chemical compound contain all the elements in the same proportion. Okay, so later in another video, I'll be explaining more about this conservation of mass, constant composition, and multiple proportions. So the multiple proportions first, let's state this law. The law was formulated by John Dalton himself. The law states that the elements in a compound have a proportion of those chemical compounds that can be expressed in a small whole number. Kung napapansin nyo, class, when we balance chemical formulas or equations, napapansin nyo, hindi tayo naglalagay ng 1.5, hindi tayo naglalagay ng 2, hindi tayo naglalagay ng 2.5 or 3.1 or something, or naglalagay tayo into a whole number para mas madali. And this was stated in the multiple proportions. Okay, in Dalton's theory, Democritus was the first one who proposed that the idea that matter was composed of indivisible particles. Pero mali siya. But the credit of the first organized knowledge regarding the first or the nature of the atom as supported by scientific evidence goes to the work of John Dalton. So sa lahat ng mga philosophers who gave their own theory of atoms or they give their own atomic theories, it was John Dalton who was acknowledged of the atomic theory. So John Dalton's atomic theory are the following. All matter is made up of atoms, which is correct. Okay, example is yung damit, yung table, yung TV, itong laptop is made up of atoms. Okay, an element is made out of one kind of atom. So we already discussed this in our first lessons that an element is made up of only one kind of atom. Example is hydrogen and another one is oxygen or carbon. A compound is made up of a combination of different kinds of atoms following a specific ratio. Okay, example na compound is water or we have a chemical formula of H2O. Tinawag siyang compound kasi it is made up of two or more element or an atom. Pag hydrogen lang element siya. Pero pag hydrogen and oxygen na, it is a compound na. And sabi dito, it has a specific ratio. Example, ratio ng water, H2O. Therefore, in every molecule of water, there is a two hydrogen atom and one oxygen atom. Kasi example, hindi na siya water pag H2O2. Kasi pag H2O2, it is already a hydrogen peroxide o yung nilalagay natin sa mga sugat. Okay? Dapat daw in specific ratio. Pag water, H2O lang talaga. Kasi pag hindi na siya H2O, hindi na siya water. The fourth one is, an atom cannot be created nor destroyed. Katulad niya sa law of conservation of mass, kung ilan mass ng reactants, same of the mass of the product. Okay, the next one, we have the atomic structure. So this is a model of an atom. Inside an atom is a nucleus which is composed of a neutron and proton. The neutron is neutral, which is ibig sabihin wala siyang charge, while the proton is a positive charge. Okay? Napalibutan rin yung nucleus ng mga electrons. Okay? So ibig sabihin itong mga spaces dito is wala ibig sabihin ito napaloob dito is may mga spaces sa atom. An atom contains a nucleus located at the center. It is consists of protons and neutrons, while the electrons are located outside of the nucleus and are much smaller. Okay? So atom is the smallest particle na makikita sa mga matter, pero yung mga subatomic particles ng atom is smaller than the atom. These three subatomic particles, proton, neutron, and electron, electron is the smallest one. Okay, electrons. Around early 1890s, when British physicist J.J. Thomson worked on the cathode ray experiments, it was J.J. Thomson again the one who discovered the electrons in his cathode ray tube. So this image of a cathode ray tube, ito yung parang mukha talaga ng cathode ray tube na napaloob sa likod ng mga TV natin, yung mga old TVs, yung mga malalaki pa. Electrons are small, negatively charged particles that spin around the nucleus, staying their orbits, shell, or energy level. The shells are numbered depending on how close they are to the nucleus. The level closest to the nucleus is numbered as 1. The next is 2, and so on. Electrons in the lowest energy level are the ones most tightly bounded. Okay, so if we base on this picture, itong nucleus daw is made up of positive, which is a proton, is a neutron. And meron siya nakapalibot rin na energy level na merong symbol na N. Energy level or orbits or shell yung tawag. And pag mas malapit yung energy level, it is called or it is numbered as 1 and so on and so forth. So N1, N2, N3. And in this orbit, shell or energy, dito nakapaloob or nakalagay yung electron para siyang solar system. Okay, and it's also stated that electrons in the lowest energy level are the ones most tightly bounded. So which is the smallest energy level here or the lowest energy level? Okay, the N1, siya yung pinakamalapit. Bakit daw it is most tightly bounded? It is because, sabi niya kanina, opposite attracts. So, the negative charge of electron attracts the positive charge of the nucleus. By the way, the charge of the nucleus is positive since merong proton na nakapaloob. The charge of the electron is negative. Okay. And then neutron is neutral. So, electron that is closest to the nucleus is most tightly bounded kaysa dito sa mga electron na makikita sa N3, N4, or N2. Ibig sabihin, itong malayo na ng mga shells, orbits, or energy level, mas madali silang matransfer or mas share sa other atoms kesa ditong sa mga electrons na napaloob sa mga N1. Particle is the proton. In the early 90s, it was Ernest Rutherford who worked on the Goldfall experiment, which I already discussed earlier. Results showed that the majority of the particles were either undeflected or deflected. In some rare instances, particles were deflected at angles greater than 90 degrees and some were deflected back. Okay, some were undeflected or non-deflected particles. Okay, some deflected or bent, and some were deflected back or rebounded. To explain these results, Rutherford proposed that atom is mostly an empty space, accounting for the undeflected particles passing through. So sabi ni Rutherford, yung atom is composed mainly of empty space since maraming non-deflected or undeflected particles na nakapass through. Okay, so he proposed another uh, atomic structure para panlaban doon sa plum pudding ni J.J. Thomson, but also containing a concentrated dense center accounting for the particles deflected at larger angle. Pero of course, he also considered na meron ring nag-bounce back or deflected na mga particles. So sabi niya meron daw dense matter na mabigat dyan sa gitna, which is the proton itself. Next one is the neutron. It was English physicist James Chadwick who proved the existence of the neutron, a subatomic particle roughly the same as that of a proton but electrically neutral. So as you can observe in the image, meron tayong electron negatively charged, proton positively charged, pero yung neutron is wala siyang charge. It is a neutral. Protons and neutrons are located in the nucleus kung napapansin nyo. Magkasama yung proton and neutron sa gitna. Okay, makasama sila sa nucleus, napaloob sa nucleus. Okay, protons and neutrons are located in the nucleus of the atom and are now collectively called nucleons, with their collective mass comprising the significant mass of any given atom. Okay, class, that's why if we're going to ask what is the mass of an atom, we mainly focuses on the mass of the proton and the neutron since the mass of the electron is negligible. Sobrang light kasi ng mass ng electron. Kaya nang sabi ko nga kanina, atom is the smallest particle of matter. Pero yung mga subatomic particles nila ay mas maliit pa. Okay? And dito, between these three subatomic particles, yung pinakamaliit is yung electron. So this table also can be found on your book. So the particles are electron, proton, and neutron. The symbol for electron is letter E with a negative sign. Proton is a P with a positive sign, and neutron as letter N. So you can already read this charge with a column and mass as grams in your book also. Okay, so class, this ends our lesson for this week. I hope you learned something or you learned more from this discussion. Be safe, stay healthy, and God bless.